Hey everyone, and welcome back to this class, Advanced Convolutional Neural Networks. In this lecture, we are going to look at how to use an industrial strength library to do object detection, and in the next lecture, we'll modify the code a little bit to make it work on video. That way you'll end this section with some very practical knowledge. You'll be able to apply SSD to any image or video that you want. But in this lecture, I'm going to walk you through Tensorflow's own tutorial so that we're better prepared for the next lecture. To start, you'll need to go to github.com/tensorflow/models and check out this code onto your local machine. Next, you want to start a Jupyter notebook from the folder research/object detection. We're going to be looking at the notebook with the file name object detection tutorial. So at the top, we import all the stuff we're going to need. Notice how you'll need to have upgraded to at least TensorFlow version 1.4. This might be troublesome for some of you. If you have a Mac with a GPU, then it's very non-trivial to get things working with later versions of TensorFlow, since they are not officially supported. If that's the case, then I'd suggest setting up the CPU version of TensorFlow in a virtual environment. Next, we import some utils from the repo. These will help us map from class indexes to class names, and also draw bounding boxes with labels on top of the original image. Now it's time to load the model. By default, it points to a neural network called MobileNet using the SSD algorithm. What's actually cool about this is that because the entire algorithm is built as a TensorFlow graph, you're allowed to load up completely different graphs as well. For example, some powerful algorithms that we didn't discuss, such as faster RCNN, are also available. So you can click this link, Detection Model Zoo, which takes you here. So you can see the different models available, what kind of performance they get, and so on. Note that for the next few blocks of code to work, you'll need to have installed protocol buffers on your system. If you don't know what protocol buffers are, you should definitely read about them as they are a pretty cool concept. Essentially, they allow you to serialize objects and then read them in different programming languages. To install protocol buffers, it depends on what OS you're on. So here are the commands for Mac, Linux, and Windows. For Mac, it's brew install protobuf. You'll want to install Homebrew on your Mac in order to do that. On Windows, assuming you're using Anaconda, it's conda install -c anaconda protobuf. And if you're on Ubuntu or Debian, you can do apt install protobuf compiler. Once you've installed protocol buffers, you can check that it's been installed correctly by running protoc ---- version, and it should print out the version. If that's all good, then you can run this command, protoc object detection /protos /star.proto -- python out equals dot. Notice the dots, don't forget these as they are very tiny. This is going to create all the files you need to run the rest of the notebook. Okay, so back to the notebook. We are going to download the file we specified in the previous block. Next, we are going to load the graph we just downloaded into memory. Next is just some grunt work. So we need to create a mapping from class indexes to class labels using the util we imported earlier. We also define a function to load images as a NumPy array. Note that later on we won't be using this function because we'll be loading in individual video frames as NumPy arrays using a different library. Finally, we are ready to do some object detection. First, we need to tell TensorFlow where to look to grab the images for testing. Note the format it expects here. We're looking in a folder called test images, and we want files to be in the format of image number.jpg. You can, of course, just replace all this code with your own image files, or you can just paste some of your own image files into the folder test images, as I've done. Either way is fine. Next, we have our detection loop. So you see how this is going to be really easy to modify to work on video. This is already a loop, and a video is just a collection of images. So all we have to do later is, instead of telling Tensorflow to look in a folder for images, we'll load a video file and extract images from it, one frame at a time. The first thing we need to do in this block is get all the Tensorflow graph nodes. These are either placeholders like the image input, or output graph nodes like the detection boxes, scores, and so on. Luckily, the Tensorflow team has made the entire thing as part of the Tensorflow graph, so there's absolutely no work to do. Next, we loop through each image file name, load the image, convert it into a NumPy array, run the graph nodes in a session, and then use the visualization util we imported earlier to plot the image along with the bounding boxes. So let's scroll down and look at the results. I've already run this, so we don't need to do it again. Okay, so here is 2 dogs which were successfully annotated. Here's some kites and some people. I believe that these 2 images were already part of the repo. So here are some images I added. All of these are just random. I don't remember how I found them. So this, it doesn't find anything. Here's an umbrella. Although I feel like there's a shopping cart on top of the umbrella. Here's a dishwasher, it doesn't find anything. Also remember that this is not the most accurate model in the detection model zoo, but it is the fastest, so we just stuck with that one. So if you want to try to get a more accurate model, you can try to load up one of these other ones, but they take longer. Okay, here's a car. It doesn't find that. Maybe it's because it's at a weird angle. Here's a car that's found. It doesn't find the boat, though. I'm not sure what this is. Here's a boat and a car. Neither are found. Here are a bunch of cars that are found. Here's some cars and traffic lights. So not all the traffic lights are found, right? There's some here on the right side that I can't find. Here's a backpack. That's pretty good. I wouldn't have thought that that was a backpack. And here's a person. Here's a dog and a bowl. Refrigerator. So it can recognize a partial refrigerator. And a partial car. Okay, car and dog. It's not a dog, but it is a 4-legged animal. And by the way, by default, these labels are very tiny, so you may not be able to see them with the code that you check out. So I'm going to show you the code that I edited in the Tensorflow repo to make these a little bigger. Alright, so if you go to the file visualization utils, you're going to see a part in the code where they're loading up an image font. So my computer didn't have Arial.ttf, so it went with the default image font, for which you cannot set the font size. So what I needed to do was make sure that Arial.ttf was available, and then change the font size using this TrueType function.